be talking about operations with polynomials, including all of your exponent rules. So here you can see a list of all of the different rules. I'm not going to go over all of them, but if you do want to come back to any of them, feel free to come and look here. The biggest one I did want to talk about is the negative exponents. Negative exponents need to be moved from the numerator to the denominator or vice versa in order to make the exponent positive. So move negative exponents and then simplify after that. And as you can see, like there's a bunch of different rules. Again, come back here to whatever you need. The other one I wanted to talk about was a sign rule. It's talking about positives and negatives. Basically, if you have a negative raised to an odd power, it's going to remain negative. So negative 2 to the third power stays negative, whereas if it's raised to an even power, the negative multiplied an even number of times means it ends up being a positive instead. So we're going to start off by dealing with zeros. So 0, the fifth power, is saying multiply 0 5 times. So this is going to be 0. 0 to the 0th power, normally we say anything to the 0 power is 1, but if you try to raise 0 to the 0 power, you're going to get undefined. And you can always check that on your calculator. Try 0 to the 0 power, it's going to be an error. 0 to the negative third, normally we would move that to the denominator and make it positive. But by moving it to the denominator, we're actually dividing by 0, and we can't do that. Therefore, this is also undefined. Negative 3 to the 0 power, when you have 0 as an exponent, you should get 1 as your answer unless it's 0 to the 0 power, as we have previously talked about. This next one looks like the same problem, but the negative is actually not being raised to the power. In order to raise the negative to the power, it would have to be in parentheses like in D. So this is actually saying negative and then 3 to the 0 power. So therefore, the answer here is going to be negative 1. So we are going to dive right on in here with our exponent rules. So we have all of these different fractions being raised to the exponent power. There are so many different ways you can do this. I'm going to kind of show two different methods, one with each of these. The first method that you can kind of do for this is you can just raise everything inside to the power first. So 2 to the negative third, x to the negative sixth. Here we multiply if you already have an exponent, so y to the negative 9 and z to the negative 3. Over 3 to the negative 3, x to the negative 3, y to the negative 12th, and z to the negative 9. Again, we're multiplying our exponents that are already there. The other option is if you don't want to raise everything in the parentheses to the power first, you're allowed to simplify first. So I'm going to show that with the other fraction so that you can kind of choose which one you like. So in here, x to the 0 power goes away. That's just 1. The y's, one of your y's would cancel out, so you'd be left with 2 y's in the denominator. So we have x to the 4th, y squared in the denominator. Your z's, one of these would cancel out, and you'd be left with 2 z's in the numerator. And then you have 4 and 3. Those don't reduce or cancel at all. Then, after simplifying, you can now raise everything to the power. So you get 4 squared, z to the 4th, 3 squared, x to the 8th, and y to the 4th. With the first one, if you raise everything to the power first, now we want to go through and move all negative exponents. So I always circle my negative exponents, identifying that these are the ones that need to move, and then I move them, and then I simplify. So I do 3 to the third power goes to the numerator. So does x to the third power, y to the 12th, and z to the 9th. 2 cubed, x to the 6th, y to the 9th, and z cubed, then go in the denominator. And at this point, we can continue to simplify each of these. So I'm going to go ahead and do 3 cubed is 27, 2 cubed is 8. For my x's, 3 of them cancel out, and I'm left with 3 x's in the denominator. For my y's, I have 3 left in the numerator. And for my z's, I have 6 left in the numerator in my first fraction. In my second fraction, 4 squared is 16, 3 squared is 9, z to the 4th is in the numerator, and x to the 8th and y to the 4th is in the denominator. Then what we can do is we can kind of reduce these. Everything in the numerator goes together and everything in the denominator goes together when we're multiplying them. So I can actually cross reduce here. So 16 divided by 8, that's going to reduce to 2 over 1. 27 divided by 9 is going to reduce to 3 over 1. My z's are going to combine because they're in the numerator together, as are my x's. But my y's are going to cancel each other out. So these 3 y's up on top here are going to cancel out 3 of these, and we're going to be left with just 1. So now I just have to multiply everything that's left. So I have 3 times 2 in the numerator, which is 6. I have 6 and 4 z's for a total of 10 z's left in the numerator. I have no numbers to speak of in the denominator other than 1, which I'm just going to leave out. X to the third and x to the 8th simplify to x to the 11th, and then I have 1 y left in the denominator. So all of this would simplify to 6z to the 10th over x to the 11th and y. And it has pretty much all of your exponent rules in that one problem there. Okay? So let's take a look at B. This one looks very different. You know, you're looking at it, and you're like, okay, it's not too bad, and then all of a sudden you notice that your exponents are m and n. As you're looking at that, if it was like 2 to the third power and 2 to the fifth power, you would look at that and say, hey, all I have to do is add my exponents, and it would be 3 plus 5, which is 8, and I would leave my base alone. The same idea occurs here. I'm going to leave my base alone, and I'm just going to take my exponents and add them together. Oops, that's not 2, that's an n. So you get 2 to the m plus n, and that's all we can do. That's our final answer. Okay, let's go ahead and take a look at some definitions here. A monomial is one term. It can have more than one variable in there, but you cannot be separated by addition or subtraction. So a couple things, your exponents cannot be negative. So you have to have positive exponents. Your exponents have to be integers, which means no fractions for your exponents specifically. You can't have any variables in the denominator. So no negative exponents, no fraction exponents, no variables in the denominator. So that's monomials. Constants are just a constant number or a constant value. So there's no variables associated with them, so you can see all of these numbers here. Pi is still a constant because it is just a value. It's not changing depending on a variable. It's just a number. Your degree is the degree of the monomial with the highest degree. So looking at these ones, you can see that A through F here, some of these are monomials, some of them are not. We need to determine if it's a polynomial, and if it is, we need to find our degree. So our first one here, yes, this is the polynomial because there's no negative exponents, there's no fraction exponents, there's no variables in the denominator. The degree is weird though, because if I were to ask you how many variables do you see, you would look at that and you'd say, well, I see none. So the degree here is 0 because there are 0 exponents. You can think of it as x to the 0 power would become 1. So therefore, that's why it's just 10 here, because you can imagine x being to the 0 power, therefore creating just the constant. Number or letter B here, yes, this is a polynomial because it follows all those rules. Each of these is separate terms, so we look at the degree of each of them individually. This first one has 1, because it's an exponent of 1. There's one variable there. This next one has 0 variables there. So the overall degree is going to be the highest between the two, which means the degree is 1. For C, yes, this is still a polynomial. You might be thinking, well, there's a fraction, and that's true, but the fraction doesn't have any variables in the denominator. So you can imagine this 1/2 being out in front. You'd look at that and say, okay, that works, but so be careful with that. This is all one term. It's a monomial. So in order to find our degree, we're going to take and add all of our exponents together. So there's 1x, 1y, 2 z's. Overall, there are 4 different variables in this monomial. So therefore, our degree here is 4. D is a polynomial. because again, there's no negative exponents or fraction exponents or variables in the denominator. There are 3 terms. It's a trinomial. So within each term, you have to ask yourself, how many variables are there? And so we're taking and we're adding our exponents together. And then you look for the highest one. So our degree for this one is also 4. For E, this is our first one where we're going to say, no, this is not a polynomial. The square root of x can be written as x to the 1/2 power. So that's kind of new to us. This is the first time we have a fraction as our exponents. And it didn't look like we had it at first, but this one was kind of cloaked. It did have a fraction for an exponent there. The next one is also no, it's not a polynomial because you can't have variables as your exponents. You might be used to seeing something that looks like this. This is an exponential function. That means it's not a polynomial because of where that x is. So if things are polynomials, we can actually just add and subtract them and multiply them just like you have been doing in all of the chapter 5, the quadratic stuff. You've been adding and subtracting and multiplying these. So this is nothing new. To add, subtract, and multiply, if there's parentheses, we're going to go ahead and distribute. So this first one becomes 4xy squared, and then a 12x squared y minus 8x squared y squared. This next one, we do have to distribute the negative sign to everything, so negative 20xy minus 5xy squared and 3x squared y squared. Then to combine like terms, they have to have the same variables with the same degrees. So looking at this, I'm going to find my highest degree first. This x squared y squared has a degree of 4 because there's 2 x's and 2 y's. So those come first, and that's negative 5x squared y squared. Then each of the other terms here, xy squared and x squared y, those have both a degree of 3, but they're different because one has 2 y's and one has 2 x's. So when you're writing them in standard form, the highest degree comes first, but you might be saying, well, these ones are tied. So you kind of go alphabetically. This 12x squared y has more x's, and x's come first in the alphabet, so that one's going to come first. And then the next one, we'd be left with negative 1xy squared because that one has more y's, and y's come after x in the alphabet. And then minus 20xy at the end. Okay, let's go ahead and take a look at example 4. We want to combine all of our like terms. So we first want to identify the ones that are alike, and then we need to find common denominators. So this is actually 2/8 minus 3/8. That's negative 1/8 x squared. The next one, this one has a degree of 2, as does this one, and it comes next because it has an x and a y. And so negative 3/8 minus 4/8 is negative 7/8. Next would be your y squareds, and it does have a degree of 2, but again, y comes after x in the alphabet, which is why this one goes next. So then when we add these together, we would get 3/4 y squared. For your application problems, what I would like you to do is I would like you to read through the problems and try to set them up first, and then come back here. So flashback to geometry right here. So for number 1, our area of a circle is pi r squared. So we can set it up as pi times 2x minus 1 squared. Number 2, the setup would be volume equals pi times 2x squared times 2/3 x. And number 3, the volume of a cube is the side squared, so 1/2 a cubed b, quantity cubed. Now that these are all set up, take a moment and try to simplify each of these by using your rules of exponents. Once you've tried them, come back here for the answers. Okay, you can go ahead and check out the answers here. Some of them are a little bit interesting with those pi's thrown in there, but hopefully it makes sense where everything's coming from. Thank you for listening, and let me know if you have any questions. Thanks.